In September of 2025, a team of marine biologists working off the coast of Hervey Bay, Australia, uploaded a photograph of a humpback whale's tail to a global tracking database. The software ran its comparison. It scanned tens of thousands of archived images, measuring the unique black and white pigment patterns on the underside of the fluke, cross-referencing shapes and scars the way facial recognition software maps a human face. Then it returned a match. The same whale had been photographed before, not in Australian waters, not anywhere in the Pacific. The match came from a photograph taken at the Abrolhos Bank off the coast of Brazil in 2003. The documented distance between those 2 points was 15,100 kilometers. It was the longest confirmed movement ever recorded for an individual humpback whale anywhere on Earth. That number needs to be held for a moment. 15,100 kilometers. That is roughly the straight-line distance from New York City to Sydney, Australia, and then some. It is nearly 4 times the width of the continental United States. Humpback whales are already among the most migratory mammals alive, capable of seasonal journeys exceeding 8,000 kilometers in a single direction as they move between cold feeding grounds and warm tropical breeding areas. This whale had covered nearly twice that distance between confirmed sightings. And because researchers only know the starting point and the end point, the actual distance the whale traveled through the ocean almost certainly exceeded what was recorded. The route it took, the waters it crossed, the years it spent between those two photographs, none of that is known. What made the discovery possible was a platform called Happywhale, a citizen science database co-founded by researcher Ted Cheeseman that aggregates whale photographs from professionals, recreational whale watchers, and scientists across dozens of countries. The study behind the record drew on 19,283 high-quality Fluke photographs collected between 1984 and 2025, sourced from Eastern Australia and Latin America combined. Each humpback whale carries a permanent identification on the underside of its tail. The pigment pattern does not change meaningfully across a lifetime. Every time a whale dives and lifts its fluke above the surface, anyone with a camera can record who that animal is. That system, built over 4 decades by thousands of people who were not professional researchers, is what made this match possible. The fluke patterns themselves function as biological passports, as distinctive and consistent as human fingerprints. The pigmentation is deposited during fetal development and remains stable throughout the whale's life, resisting the wear that might degrade other identifying marks. Scars and notches may accumulate over years, but these additions only increase the uniqueness of each individual's signature. The angle of the fluke, the shape of the trailing edge, the distribution of white among black patches. Each whale presents a combination so specific that the probability of 2 individuals sharing an identical pattern approaches 0. This permanence and uniqueness is what allows researchers to conduct what amounts to a long-term census, using nothing more than photographs, camera angles, and patient documentation. The whale in the 2003 photograph was swimming in a group of 9 adults at the Abrolhos Bank, Brazil's primary humpback nursery off the coast of Bahia. It was documented once, and then not seen again in Brazilian records. 22 years passed. Across that span, the whale moved through waters that researchers had no visibility into, appeared in no photo database, matched to no other record. Then in September of 2025, alone in Hervey Bay, it surfaced again. The match was confirmed, the record was set. Scientists noted immediately that the 2003 image and the 2025 image represented the 2 endpoints of a journey, not the journey itself. The 15,100 kilometer figure is a floor, not a ceiling. This was not the first time a humpback had crossed ocean basins in a way that shocked researchers. 3 years before the Australia-Brazil record was confirmed, a separate study published in the journal Royal Society Open Science had documented an earlier case. A male humpback whale first photographed off the coast of Colombia in 2013 was detected 9 years later near Zanzibar, off the coast of East Africa, in the Indian Ocean. The confirmed distance between those sightings was more than 13,046 kilometers. That record stood for 3 years. It also marked the first documented case of an adult male humpback whale traveling between the Pacific and Indian Oceans. At the time, researchers described the feat as truly impressive and unusual, even for a highly migratory species. The implications of the Colombia-Zanzibar case extended beyond the remarkable distance itself. The whale had traversed through waters that had never been documented as part of humpback migration corridors. It passed through regions where humpback populations were thought to be absent entirely. The sighting near Zanzibar represented the first confirmed photograph of a Pacific origin whale in the Indian Ocean breeding grounds. suggesting that the geographic boundaries researchers had mapped were far more permeable than previously understood. The discovery prompted additional scrutiny of archival records and careful review of photographs that might have been dismissed as misidentifications or errors, opening the possibility that other interoceanic movements had occurred and simply gone unrecognized. Together, those two cases represent something that was previously considered essentially impossible. Prior to these findings, the dominant scientific understanding held that humpback populations across different ocean basins were largely isolated from one another. Whales returned to the same breeding grounds year after year. That loyalty to specific locations was considered one of the defining behavioral traits of the species. The idea that individual animals were crossing between major ocean systems, switching breeding grounds entirely, crossing from one hemisphere's population into another, had not been seriously modeled. The data said it did not happen. Then it happened twice, both confirmed, both documented through photographs, both verified against databases containing nearly 2 decades of accumulated images. The rarity of what these two whales did is not softened by the fact that it happened twice. Researchers who analyzed the broader dataset found that such interoceanic crossings occurred in approximately 0.01% of all identified humpback whales in their records. Out of thousands of catalogued individuals tracked across decades, 2 had done this. The behavioral pattern is not a population-level phenomenon. It is an extreme outlier repeated just enough times to become scientifically undeniable. Each case represents a single animal making a decision, or responding to a pressure that took it beyond the boundaries of what the rest of its species does. The Colombia to Zanzibar whale was a male. That detail matters. Male humpback whales compete aggressively for mating opportunities in their traditional breeding grounds. The waters off Colombia, part of the eastern Pacific breeding population, draw large numbers of humpbacks each season, and competition among males is intense and physical. Cheeseman, the lead researcher on the Colombia-Zanzibar study, suggested the whale may have left in search of a less competitive environment. Fewer rival males, more accessible females. The Indian Ocean off Zanzibar represents a breeding ground for a completely separate humpback population, one the Colombia whale's genetics had likely never entered before. If Cheeseman's hypothesis holds, this was a male that lost the competition at home and traveled 13,000 kilometers to try somewhere else. The Brazil to Australia whale's motivations are harder to assign. The 2003 photograph places it among a group of adults at Brazil's primary nursery, a gathering site used heavily for mating and calving. By 2025, 22 years later, it appeared alone in Queensland waters. Australian humpback populations feed in Antarctic waters and breed along the Queensland coast. Brazilian humpbacks follow a different corridor entirely, moving between Antarctic feeding grounds and the warm shallows of Bahia. These two populations have historically been treated as separate groups, with separate ranges. This whale existed in the overlap between them. It spent more than 2 decades doing something between those first and final photographs that left no record anywhere in the database. Climate change has entered the scientific conversation around both cases. Warming ocean temperatures are shifting the distribution of krill and small fish, the primary food sources that drive humpback migration patterns. As Antarctic ice coverage changes, the cold, nutrient-dense waters that humpbacks rely on for feeding are moving. Some researchers have proposed that the whales making these extraordinary crossings may be responding to disrupted food availability in their home ranges, searching for productive feeding areas in unfamiliar parts of the ocean. Others point to the broader recovery of humpback populations as a potential driver. Commercial whaling devastated global humpback numbers across the 19th and 20th centuries. Since protections were established in the 1960s, populations have rebounded sharply. More whales competing for the same resources means more pressure on individuals to find alternatives. The recovery itself, intended as a conservation success, may be creating new pressures that push individual whales beyond their ancestral ranges in search of adequate food and breeding space. Humpback whales can live between 80 and 90 years. The Brazil to Australia whale was photographed as an adult in 2003 and confirmed again in 2025. Across that span, it would have completed multiple full migration cycles every year, moving between cold feeding grounds and warm breeding areas, covering thousands of kilometers annually just as part of its ordinary life. The 15,100 kilometers between its 2 documented positions is the exceptional distance, the anomaly, the figure that sets the record. But behind that number is an animal that has been migrating continuously for decades, accumulating a life history that scientists have glimpsed only twice, at 2 points separated by 22 years and an ocean. The technology that enabled these confirmations did not exist in a meaningful form when the first photograph was taken. In 2003, Photo identification databases for humpback whales were regional, incomplete, and largely disconnected from one another. A researcher in Brazil and a researcher in Australia had no practical way to cross-reference their images. Happywhale changed that by building a centralized, globally accessible system, layered with artificial intelligence trained to recognize individual flukes across massive image archives. The same kind of software used to identify human faces was adapted to read the shapes, edges, and markings of whale tails. When the 2025 Queensland photograph was uploaded, the system searched across every image in its archive and returned a match from a Brazilian database that was more than 2 decades old. The collaborative structure behind that system is what gave it power. Whale watchers on tourist boats, recreational photographers, research vessels operating in completely different ocean zones. Every photograph uploaded into Happywhale extends the reach of the archive. The Colombia Zanzibar case was resolved the same way. A photograph taken by a whale watcher near Zanzibar was entered into the platform. The algorithm flagged it against Colombian records. What would have been an undetectable crossing became a confirmed data point. Both record-breaking discoveries came not from dedicated tracking programs or satellite tags, but from accumulated citizen science images matched by machine learning. What the records reveal, beyond the raw distances, is that humpback whale populations are less isolated from one another than decades of research had indicated. The genetic implications of inter-oceanic crossings are significant. A male that breeds successfully in a population it did not originate from introduces genetic material that would not otherwise enter that lineage. Over generations, if these crossings occur even rarely, the genetic structure of geographically separated populations could be more connected than current models predict. Researchers have called this behavioral flexibility, the capacity of individual animals to deviate from the norm of their species, and described it as potentially important for long-term adaptation as ocean conditions continue to shift globally. Conservation strategies built around the assumption of isolated populations may need revision to account for corridors and crossings that are now documented to exist. Marine protected areas are generally designed around known migration routes and breeding aggregation sites. If humpback whales are crossing between ocean basins at even fractional rates, the corridors they use during those crossings run through open ocean stretches that receive no specific protection. The Colombia whale moved from the Pacific into the Indian Ocean through waters off southern Africa. The path is unconfirmed, but any route between those 2 points crosses multiple national jurisdictions and vast stretches of international water. Protecting a whale that has left its known habitat and entered an entirely different ocean system requires a level of international coordination that current frameworks are not built to provide. The Abrolhos Bank photograph from 2003 shows a whale in a group of 9, moving through one of the most important humpback breeding sites in the South Atlantic. Nothing about that image predicts what would be confirmed 22 years later on the other side of the world. The whale was one animal among many, untagged beyond the natural markings on its tail, carrying no instrument that would allow anyone to follow it. What followed that photograph is a 22-year gap in the record, a span covering more distance than any humpback whale had previously been confirmed to travel, and ending with a lone whale surfacing in Australian waters in September 2025, its fluke photographed again, its identity returned by an algorithm in seconds.